Okay, my talk is search engines in .NET. This is me, Brendan Richards. I'm a solution architect at SSW. So what I'm going to talk about is why use indexes, and then I'm going to talk about Lucene. So Lucene is an open source library for search indexes. I'm then going to take the story of Lucene and follow it right the way through a number of different products based in various ways on Lucene. So I'm going to cover Lucene.net, which is a .NET port of Lucene, Elasticsearch, which runs Lucene in the background, and Azure Search, which runs on top of Elasticsearch. So why search indexes? Why are we looking at this technology in the first place? Well, the best thing about SQL databases is they're a good general purpose data solution. You can do pretty much anything with them. The worst thing about SQL databases is they're a general purpose data solution. They're not going to be as fast or optimized for certain tasks. SQL Server itself does have a full text search engine, full text indexing feature, but it's not very good, and it's not as good as what I'm going to show you here. Indexes are focused on one thing, doing that search. So I'm going to show you some search options that are faster and have more features than anything you can get from a database. So really, what makes an index is how the data is stored. In SQL, everything's about relational structures. You've got tables, you've got columns, you've got relationships between those columns, and the whole point is everything about that data is meticulously preserved and maintained. You've got data integrity, keys and typing. You've got updates and constraints, transactions and stored procedures. But in an index, the way the information is stored is optimized only for search. In some cases, you might not get all the data back out of an index that you put in. If your main data store isn't that index, you don't actually need to keep that data in the index itself. So you take that data you put in and break it up in a format that gets it working for an index lookup. Generally, in an index, you can search and retrieve your data, but you can't work on it like you can with an SQL. You can't join, you can't do work on it in place. You can only kind of re-index. There's a few exceptions to that rule, but I think it's best to walking forwards to keep that rule in mind. So now we've talked about why, let's talk about Lucene. So Lucene is an open source Java library for search, and it's been around for quite a long time. It has a .NET port, Lucene.net, which I'm going to show you a little bit later. And the .NET port, Lucene.net, has been used by both Stack Overflow and RavenDB. So in RavenDB, it's a NoSQL data solution. If you want to get your data back out with some kind of search query, it's actually a Lucene search index in front of it. So Lucene is a core engine for many search products. And I'm going to show you the Lucene story across all of these, including Elasticsearch and Azure Search. So Lucene's been around a long time, 1999. Lucene.net, the .NET version, came out in 2003. It's a formal Apache Software Foundation product. Apache Solr was the first product that was built on top of Lucene and turned it into a full search server in its own right as a product. Elasticsearch first came out in 2010. 2012 is when Lucene.net 3.0.3 came out. That's important because that's the current version. So that's quite an important thing to keep in mind. Moving forward through times, quite recently, 2016, Elasticsearch is now on version 5. You might see a bit of a jump from 2 to 5. What happened was Elastic had a whole suite of products, and they decided to unify the version numbers where they previously had lots of different version numbers. So they took the lowest common denominator. They had, I think it was, one of their products was on version 4, so they moved everything up to version 5 this year to have a unified one set of products with one version number. So next I'm going to talk about the core features of Lucene. So what is it about Lucene that makes it work for searching? Well, first and foremost, while we're here, while we're having this talk, is the text search. You put some text into a box and you hit matches based on what you've typed into the box. Pretty simple. But where it becomes more interesting is how it then scores and ranks those results. So just like Google, the best matches sync to the top, and there's lots of algorithms to achieve that outcome. Fielded searching. Everything you put into Lucene index is called a document. And each document is a collection of fields. So you can ask for various fields within that document, just like you would with a SQL query. Boosting, this is the key feature that lets you manipulate a document score. So every time you run a search query in Lucene, every document you get back is given a score, and boosting is how you modify that score. Boosting at a document level boosts an entire document score. Say, for example, you wanted to make an algorithm that looked through web pages and started to promote web pages that had lots of other pages linking to them. Don't know why that would be useful. But if that's the algorithm you wanted to do, then a document-based boosting level is how you do it. You can boost a particular field. Say, for example, you think the title field is more important than the content field. You can boost the title field. Or you can apply boosting dynamically. So while actually building your query, you can actually boost a particular field. Lucene's, as the engine's got quite complex queries and filters. You can use filtering. So where the search query, it's kind of fuzzy. It will give you a fielded search where a word appears in the text, and the more times the word appears, the higher the score. Filtering is for completely locking out. So it's more like a SQL query in give me fields where this is this particular value or not this value. Phrase queries. You can query entire phrases. You can also do fuzzy and wildcard queries. So put a star in the middle of your query and things like that. Proximity is where two words in a phrase are matched higher based on them being closer to each other in the actual document. So if you've got the two words appearing in the same sentence, there's a higher score than one appearing in paragraph 1 and appearing in paragraph 2. Range queries is more about your kind of date ranges and number ranges. And finally, one core feature of Lucene is stemming. So stemming is taking all the various versions of a word, like emails, email, and emailed, and putting them all to one root core word, so that when you're searching, those minor versions of the same word will hit. And obviously, stemming requires a library that's customized for the language you're working with. So if you're looking at supporting an unusual language, you'll probably find somewhere on the internet that will give you support for that language. The other feature that Lucene gives you as a library is hit highlighting. So when it gives you results, it can give you fragments from the document with the matching terms highlighted. So we've looked at Lucene. The next thing we're going to look at is Lucene.net. So Lucene.net is a .NET version of the Lucene library. So what it is a class-by-class port from Java. So they took the Java source code at one day, took all the classes in it, converted it to .NET, and then launched that as a product. Which means when you're looking at Lucene.net, all the documentation for the Java version applies, including the full Java docs. Every single class in the Java docs for the Java version is there in the .NET version. It's currently a stable release. It's been out for a long time, and it's been used in some very high-profile projects. So the core thing about Lucene.net is it lets you embed Lucene actually inside your .NET application. Okay, I'm going to run a few demos now, and the first thing I'm going to do is actually show you how I'm going to get some data, because I need some content to actually index and work with. So at SSW, we have a site called rules.ssw.com.au. So this website is basically a whole series of rule content about web development and being a contractor. And we continually contribute to this rule set, but for these purposes, it gives me a big set of content that I can index. Of course, it's a slightly ridiculous example, because obviously this site itself is in SharePoint, and SharePoint already has a brilliant search. In fact, so brilliant we gave up and used Google instead. So we've got the site up there on a website. It's indexed, it's searchable already via Google. But what we're going to do is we're going to use the REST API. Don't know if you can see it, but what you're looking at here is a Postman screen. And basically, the rule content that we need to index comes out in a big JSON blob. So what I've done is I've taken that content and I've created a rule domain object. So all the different examples are going to be using this object, which just has some content, a title, and an ID. And we're going to be indexing this content. And this is how we actually fetch those rules from SharePoint. So nothing too too clever. We just do a HTTP request. We then convert it to a J object using Newtonsoft JSON to turn it into an enumerable of type rule. Okay, so once we've got some rules, how do we then push that into a Lucene index? So I'm going to show you some core Lucene objects, and those objects are directory, analyzer, and index writer. I'm then going to show you how to index some documents, build some documents, and index those documents with index writer. Okay, so the core objects you need to know about when working with Lucene are all here on this one line. I've basically, in my code, I've created a Lucene context, and these are the objects that that context holds. Firstly is the directory object. So the directory object is one single thing to store your index. Now you've got in-memory directories, and you've got file system directories. The whole point is being here is this directory is a singleton. It's 100% thread safe, but you create one of these per your application. So if you point it at a file system one, it will take ownership of that file system, of that folder in the file system, and lock it, hold on to it. I've actually had problems when I was using this with an MVC project, because when you run Visual Studio, in the background, Visual Studio will try and build up a second copy of your website in order to give you IntelliSense. Well, when that happened with me, both copies then tried to grab part of that directory folder, and I was getting all kinds of errors. So I ended up putting Lucene into a little standalone service to keep it separate from my web application. So the directory is where you store your index. The analyzer is the engine that can process text and turn it into an index. So you have a singleton directory, you have a singleton analyzer, and then the next object, the index writer, is the object you use to actually write your index. So that has the add document, that has the commit command. So all those three things, you generally have one for your application, and they're all thread safe. The final object here is the index searcher. So the index searcher is going to actually fire queries and get data back out of your index, and that's generally that's more like a kind of database connection. It's you create and dispose of it many times as you walk through. Okay, so if I want to index something, I've got to create a document. A document is a collection of fields. So with this code here, you can see that what I've created a little mapper to take my raw model and turn it into a document. So each document is a collection of fields. It's a bunch of settings, whether it's stored as a field, whether it's analyzed. So your ID, for example, you don't analyze that. You don't process that with the text parsing to turn it into an index. You just store it as is, and you can bring it back. Whereas your title and your raw content and your publishing content, you do. One thing to point out, and this will be common across the whole thing, is when you're talking to a database or a data table in a column, you assume that you have one of each field type. This search index document makes no such assumption. You can see here in this loop where I'm looping through a list of keywords. In order to index those keywords, I'm just adding them again and again and again to the same field. So each field can actually contain a collection of strings. And that becomes apparent when I do the reverse operations. When I take a document and turn it back into a rule, all the ones that I expect to be a single field, I'm actually calling first or default on those, apart from the keywords. So actually getting collections of strings is easier to get out of an index than getting just a single string. Okay, so I've created a mapper that I can use to take a ruled object and turn it into a Lucene document. Then in order to index it, the important piece of code is this. The important piece of code is this writer.addDocument, and then this document builder.to document is the map you've just seen. So you take a document object, put it to add document, that registers it with the writer to be saved. Then to commit that change, if you've got 100 documents, then you do the 100 documents, then you do writer.commit to actually commit that into the index. Okay, so we've used that piece of code, we've put stuff into a Lucene index. Let's take a look about how we get that back out again. And now I'll run to some code. Actually, I'm on the right. So what I've written here is a little integration test, just so I can run this in debug mode and see what's coming out. So we get our context object, which is the one I've created that contains all our top-level singletons. And then to do a query, I build a query parser object. I need to pass in the analyzer. I then give it a query, so that's the query string. I then run indexsearcher.search with that query, and I say I want 20 results. So let's run that test up to this breakpoint and see what we get back. Okay, here we are. We've run up to that breakpoint. Now we can have a look at this search results object. And what we've got is a max score, which is the highest score of all the documents we've received, and then a list of score documents. And each one is an ID and a score. So in this particular library, what we're getting back is a list of scores and a list of references. If we then want to load the whole object back again, we actually need to take that score and use the index searcher to retrieve the document again. So the results here is just a list of IDs and their score, and then to fetch the document back, we actually do another call to the back-end library. Okay, so the next demo, I'm building on top of that now. I've got Lucene. I can put stuff in the index. I can pull stuff back out of the index using the query. Let's actually turn that into a website that we can use. Okay, I've created a search controller and a little thing called text search. I've created an interface because I can swap out different implementations of search later on. And the important thing is here, I've taken a query string in this action result. I'm going to call text search.search, and I'm going to return a partial view of some search results. So let's take a look at that. Okay, so I'm building on the previous example now. I'm still performing a search, but I'm also going to wire in some hits highlighting. So then build some hit highlighting. I create a score object. This line of code here creates something called a formatter. So this is basically the HTML I'm going to put around each highlighted hit, and then create a highlighter. And I then run the query with that highlighter set up. Okay, so to read the results back then, I've actually got two selects, because remember from the first example I showed you, we didn't have the document embedded in the results. We had a series of tables. So I'm doing two selects. The first select I'm passing through. I'm actually creating just creating an untyped object with the score document that I got back and actually attaching the document. Then I can actually select that again and turn it into my rule search result. So my rule search result is just a reference to the rule object, its score, and the context, which is going to store the formatted hit highlighting text. So in all the examples I'm going to show searching with, this is what I'm going to transform any results back into so I can display it on the screen. So let's take a look at that running. So what we've got here is a completely standard file new project ASP.NET project. I've created a search endpoint, and let's do a search. And there it is. That quick, it's done a search against the documents that I've indexed from SSW rules, and I've got some hits there. Now, this being plain Lucene, there's quite a few features I've already got. So this text box here actually has support for quite a few extra kind of filtering options. So let's try this one first. Okay, that one searches the title field for the word email. This one, if I do a little hat sign and a 2, that's going to apply a boost at query time. Okay, so what that one has done is searching in two fields, the title and a field called publishing page content. That's just what it was called in SharePoint. But it's given the title field a boost of 2. So it's going to favor the score from having email in the title over having email in the main content. This one, this one is a proximity query. It's going to return a hit whenever the word email and task appear within 4 words of each other. And finally, you can also put ands and ors in the middle of your text. So that works quite well. That's out-of-the-box Lucene technology just with a query string. And I have been known years ago to actually I have made a system that built queries on the fly and built up that text search. But there's also a whole suite of objects that let you programmatically build up a more complicated query, which I haven't got time to show you now. But there's a lot of features there in Lucene. So let's go back to the slides. Okay, we've performed a simple search. We've seen how to do a search, and we've seen how to run a search from the website and how to read the search back. Okay, another library involved with Lucene.net is Lucene.net.link. So what this does is an extra library on top of Lucene.net that lets you write link queries. It contains something called the Reflection Document Mapper, so that you can actually build your documents automatically without having to manually map them up. And it also lets you do fluent or attribute mapping. So here's an example of a simple query with link, and yeah, it looks much more usable. And one thing I don't like about this, though, is there's kind of 2 types of operations with Lucene. There's either a search or a filter. And the link, everything looks like a filter, but in some contexts it'll be a search, and some contexts it'll be a filter. And it's really hard to tell what's what. But obviously, this whole pain of manually creating a document object, you can instead use a reflection document mapper to do that building, and you can use attributes around your model to configure that, or you can use a Fluent API sort of next to your model to configure that mapping. So there's some good things with Lucene.net.link, but there's quite a few bad sides as well. This one can get in the way if your queries are complicated, because if you know your way around Lucene and you're using Lucene.net.link, you've got to think, okay, I know how this works in Lucene, but now I've got to think about what does the link library do on top of my query I'm sending in to turn it into a Lucene query in the first place. That is it a search or a filter problem that I mentioned earlier. And also it's taking a step towards obscurity. It's not a very big or popular library. And I'll show you what I mean by this. All open source is a popularity contest. The more people using a library, the stronger the support and the more likely it's the updates. So for example, JSON.NET used by loads of people, 34 million downloads. By the time you get down to Lucene.net.link, far fewer downloads. And that's a problem. In fact, it's a problem for Lucene.net as well. So one thing with Lucene.net as a Java programmer, it is written like a Java app. Because it's a class-for-class copy from Java, it's very Java-like. You won't find any lambdas in that code base. Also, the current stable release is quite old, 2012. So it's got low-level Java-style APIs. It's ported from an old version of Lucene. Lucene itself has moved on quite a bit since that last version was made. And because it's old and no one's really supporting it and it's not moving forward, I can see that people are working towards doing a .NET Core version of Lucene.net, but it's just not coming here. So you can't use Lucene.net with .NET Core, and I think that's a big problem. So back in April this year, I had a site with Lucene, and it was working well, did its job, and I thought to myself, well, what's going on? Why isn't everyone else just all using Lucene? Why isn't it moving forward? What's everyone else up to? So I was on site of a client, I had multiple search indexes embedded across multiple applications, and had issues keeping those indexes up to date. And also I had pretty much the search server I had was a roll your own Lucene solution. So I had my own home-built service using Top Shelf. I was using Nancy to make a web API on top of that. And that meant that every time I wanted to do something with this search server that I'd made, I had to write code for each new endpoint I added. So I then looked into Elasticsearch, and I'd heard the name Elasticsearch, but there's one little thing holding me back. And that was, once you hit Elasticsearch, it is a Java server. You have to run Java in order to run it. So why does that make sense? The way I think about it is, you think of your Elasticsearch more like a database server. You don't care that your database server isn't running C#, it's just running whatever it runs. It's a service, it sits on your network, and you send queries to it. So if you think of Elasticsearch as a database server that has that library, then that's all good. It also has a very good REST API, and it has 2 .NET client libraries. So these libraries make it very, very easy to use Elasticsearch with your .NET application. Elastic Client is a low-level library that basically just gives you an easy way to call the REST API from .NET. Then there's a library called Nest that builds on top of Elastic Client to actually give you full type mapping. So you feed an object into Nest, it will map them and index them for you as a high-level object. So let's take a look at how you go about running a server. So Elasticsearch, it's pretty cool. It's a cool name, cool logo, a lot of people are taking up. So what they do is they take the Lucene libraries, create a server. They add clustering support, which means it scales up very well. They've got a REST API, which is easy to call. They add a whole bunch of client libraries, and then a huge product suite of products and extensions on top of Elasticsearch, which gives you quite a bit to work with. So to install Elasticsearch, what you have to do is just get over it and install Java. Now, none of the operating systems like Java for different reasons. With Windows, it's just not a Windows type thing, and they've always been at war. Windows were at war with Sun Microsystems, and they carried on that war when Oracle came and bought it. So on Windows, what you need to do is set the Java home environment variable. If you want to install Java on Linux, the reason Linux doesn't like Java is because it's not free enough. They'll much rather you use a totally free GPL, almost Java, but not quite Java, enough for it to not work properly. So what I tend to do, so on Windows, you set the Java home environment variable. On Linux, you've got to add a custom package source. So the setting Java home, much, much better these days on Windows. They've completely, my favorite Windows 10 feature is they've fixed this window so that you can actually set environment variables with a nice interface. And then once you've set up Java, all you need to do is just unzip the file, go to the folder, and run it. And like most Java servers, basically what you'll find inside the bin folder is a bat file for running it on Linux, a bat file for running it on Windows, and a .shell file for running it on Linux. So running on Linux sounds like fun, so let's do it that way. Okay, so in the bottom corner there, you see I've gone to the bin folder of Elasticsearch. You can see the bat file there, and then there's a file which is called Elasticsearch. If I, and you can see that starts with a .bin-bash, which is how all kind of Linux-style batch files start. So let's run it. Okay, so we're now running Elasticsearch, as simple as that. So what does that give us? Well, let's take a look at So I hit the endpoint that the Elasticsearch server is running at. Straight away, I'm using a Chrome plugin to prettify up the JSON response. But basically, it's running a JSON REST API server that I can just hit with REST calls and get JSON responses back. So straight away, that's a bit more usable and more useful than just having a library that I have to then plug into my own server. So let's take a look now at indexing some stuff with Nest. And I'm going to stay in Linux because I've recently discovered that JetBrains Rider is now usable. So everything you see now is going to be running inside .NET Core. Okay, so what you're looking at now is pretty much the same type of code you've seen before for Lucene, but this time it's using the Elasticsearch library. So we've got a query matching a field with just a search text string coming in. We've then got some code to highlight it. And this time in our results, we actually do get the document back in our results from Elastic. So we just convert that into a new rule search result. So let's see that running. And the other great thing with JetBrains Rider is this stuff just seems to work. You can create an app, you can click run, and it will actually run on Linux, which is a big deal for me. Okay, so you're seeing pretty much exactly the same feature, but I made the highlight red just to prove that it's a different engine running it. So let's get back to the slides. Okay, so the other big advantage from going with Elasticsearch is you've now got support for clustering. So Elasticsearch can scale horizontally to any number of servers. It gives you a high ability in failover. You can shard it, so you can run bits of queries across different bits of your cluster. And you can distribute queries. So you can split your data around in different shards and distribute your queries across multiple nodes. You can do this all on-premise as well, or you can do it all in the cloud. So Elasticsearch in the cloud, you can obviously run Elasticsearch on any virtual machine, but that's not really doing cloud, that's just doing virtual machines in the cloud. Or you've got Elastic Cloud, so Elastic, the company, sell their own cloud now, or you can put it in the Azure Marketplace. So the Azure Marketplace gives you some templates to actually spool up a whole set of clusters, a whole cluster of Elasticsearch servers, and you can go from there, or you can put it on a bookshop, if that's a good idea. Okay, so we've looked at Lucene.NET, we've looked at Elasticsearch. Let's move on to Azure Search. So what's different about Azure Search is is pretty much cloud only. So Azure Search is still built upon So Azure Search is still built on top of Lucene. So in the background, underneath Elasticsearch, it's just a Java server using the Lucene Java library, and they've built a whole system on top of it. Azure Search is still based on Lucene because Azure Search is based upon Elasticsearch. But what Azure Search have done is they've taken that engine, turned it into a cloud service, and put a different set of APIs in front of it. So a lot of the features you'll see are the same, and in the back end it can support the same features, but the way you get to them is very different. And one of the biggest changes is that you have to declare your schema up front. So with Elastic, you can give it an object, and without any mappings, just magically pop it into your index. That's not always a good idea. I met up with one of the support guys from Elastic the other day at Elastic Meetup, and the third word he said to me was mappings. So the first thing you ask any customer who has a problem with Elasticsearch is, what are your mappings? What have you tried to do? Because it's vitally important how that mapping works as to how Elastic's going to perform. but you're not forced to. You can just, if you've got very simple requirements and you've got an object just with some text in it, you can just put it straight into Nest and it'll just get indexed for you without having to think too much. Azure Search also has a free tier, which allows for 3 indexes and 10,000 documents, so it's good to play with. It's also got full .NET SDK and REST APIs. So let's take a look at that one. So the first thing I'll show you is how Azure does an index. Okay, so to use Azure Search, you need to use these .NET libraries, these NuGet packages, Microsoft.azure.search and Microsoft.azure.search.models. And if I scroll down from there, I've got a create index function. So what I do here is search client.indexes.exists. If I've already got the index, I delete it, and then I recreate my index. And when you create an index, you've got to define exactly what fields are inside it. So Lucene, it's pretty loose on what you can put inside it. It's just a document with a collection of fields. Elastic, again, very loose. You can put an object in, and it'll index it for you and map it for you. You're not forced to use the same thing every time. Now that can lead to problems. If you've put an object into Elasticsearch and a field is only present in half the records, if you try and search on that field, it will fall over. So it can be a blessing or a curse to be flexible, but generally I prefer the flexible. And one thing I really don't like with the Azure Search mappings are these. So basically, what's going on here? Do you know what this looks like to me? Anyone used ADO.NET, and you've got this enum of various types, the map up the types you see in the SQL server. And when you're using the raw ADO.NET, you've got to kind of check for those types. Well, this pretty much looks like that. It doesn't natively understand the thing coming in. You've got to manually specify each mapping. So it's forcing you to confront the subtle differences between your types and the types in the index. Now, I find that the Elasticsearch client, obviously, there may occasionally be problems where something you put in has been slightly transformed when it comes back out, but generally I find the Elasticsearch client Nest is very, very good at taking what you give it in a .NET world, indexing it in the Lucene index, and giving it back to you exactly the same, and just coping with what the types you feed it. So to create an index, you've got to painstakingly and manually put in all your settings. The other thing I had to do is it won't let me put in my actual data had a string had an integer for its ID, but Azure doesn't support that. So I had to actually convert my ID to a string in order to use it at all. So now I've created an index. How do I go about indexing some documents? Pretty simple. I get a client. I then I'm going to get a batch of 500 objects. And then I'm going to try and send my rule objects into the index. Now, I had issues here because I've not mapped up all the fields from my rule object. So what I had to do, if I try and push a raw rule object into this index, it would fall over because I had fields that weren't mapped. So I actually had to just take my rule object and turn it into an anonymous type here just to get it pushed in. It doesn't seem to mind stuff coming back and mapping it back in the other direction, but I had to only push fields into the index that were actually in the mappings. And the key line here is this index async. And I've got to work with async here because Azure basically forces you to be asynchronous. It's got a non-asynchronous call, just index, but it would, if you call that, it would run asynchronously anyway, and then just end your program before it's actually finished working. So there's a bit of work here trying to make an asynchronous call act synchronously, so I've got to wait for it and that kind of thing. So that's how you get stuff into the Azure index. Then to see it coming back out again, I've got yet another of these text search, And again, you should see this is quite familiar now. We've got a query. We send the query in. We send in some stuff about hit highlighting, and I've decided to make this one green. The key thing here is index client .documents.search, and this version will actually take the search results and turn it into my rule object, and then I take those results and turn it back into my rule search result, where I've got my rule object, the score, and the actual hit highlights. So let's see that working. So to do that one, I've got to just change my configuration and swap out my Elastic provider. With the Azure provider. Okay, save that, try and run. Okay, let's run this again. Wait for it to boot. Okay. Okay, and we see the search is working, and now we're getting the green highlights. So we've seen pretty much the same functionality now across all three libraries, Lucene.net, Elasticsearch, and Azure Search. So we saw how to create an index. We saw how to index a document. We saw how to perform a search with hit highlighting. Azure Search does have one more feature that's worth mentioning, and that is you can configure it with a data source and an indexer and an Azure data source, and it will actually automatically update its index from that data source over time. So you can actually register that using the API. You create this data source object. Using the API, create this indexer object that uses the data source, and then when data in that data source changes, the index of that data source will update. So that's quite a cool feature if your data's in Azure. But to make it a kind of fair comparison, the demo I've shown you has pretty much the same data coming from SharePoint and then being pushed into those different indexes. Final thing I'll show you about Azure is the actual site itself. So one advantage with Azure over Elasticsearch for inside Azure, as Azure itself, is you do actually get the stuff all about your Azure Search inside the portal libraries. If you're hosting an Elasticsearch cluster inside Azure, pretty much all Azure does is let you build up the machines running the Azure, and you have to use running Elasticsearch, and then you've got to use Azure's Elasticsearch's tools to actually see it. But you can see here, I can see some stuff about my index. I can see how many documents are in there. There's how much storage I'm using, stuff about the fields, all inside the Azure interface. I think Azure gets quite expensive once you start going beyond the free mode. And the other thing to keep in mind is that these numbers lie to you when you first index stuff. It takes a long time for these numbers to update. So I spent a good weekend quite recently just trying to get Azure Search to work and index my documents, and kept coming here and seeing no documents, thinking it hadn't worked, but it actually had. If we go to the actual look at the index, you can see it has worked. The other thing you've got here is the ability to, you can actually perform simple queries from this interface. I'll remember how. Might not be able to see it. So if I just go, There you go. So actually browse. This little tool lets you actually browse the REST API that Azure Search gives you. So let's wrap up with an overall summary and recommendations. So let's first compare Lucene.net versus a cloud solution. So first of all, the big benefit of Lucene.net is you can actually embed the Lucene engine inside your .NET app. There's no external service, it's actually there inside your application. Whereas with Elastic Azure, it's a separate service. To a certain scale size, being separate makes more sense. For a certain small app, maybe being embedded is where you want to go. Another big advantage with Lucene.net for a .NET developer is because you've got the thing running inside your application, you can customize it more. You can override the directory or the indexer. You can pretty much customize the indexing engine, where if you wanted to do that with Elastic, or Azure, you probably can't customize anything. You've just got to use what you're given. If you want to really customize Elastic, you can. It's fully open source, but you've got to know Java to do it. With Lucene.net, I had to run my own management, so I had to build my own service around the library, set up the API endpoints, whereas with a cloud service, you've got those management features included. You've got an API endpoint built for you when you install Elastic or when you install Azure. Lucene.net runs in a single process, unless you make more servers and spread it across that way, whereas you can run Elastic and Azure in clustering and the cloud. Lucene.net is based on quite an old version of Lucene, and it isn't moving forward as far as I can see, whereas everything's bang up to date in Elastic and Azure. Lucene.net, because it's just this library that was released a long time ago, doesn't have a big community. You're going to have low support and documentation, where Elastic and Azure both are quite big companies behind them now. My next comparison is Elasticsearch versus Azure Search. So Elasticsearch is based on Lucene. Azure Search is based on Lucene and Elasticsearch. So they both provide quite a lot of similar features. Elasticsearch is available in Azure through the marketplace, where obviously Azure Search is available in Azure too. Elasticsearch is scalable and clustered, and so is Azure Search. You can just turn a dial. But with Elasticsearch, you get a fully flexible schema. It doesn't kind of dictate to you up front what I want to put in my index, where Azure Search has a very, very fixed schema, and the way it does the mappings with its kind of list of predefined types, almost like ADO.NET does it, I don't really like it. Elasticsearch is well established, it's been around a long time, got a lot of uptake across the whole developer spectrum. So it's a product that's kind of big in the Java world, it's big in the Ruby world, and it should take off in the .NET world too. Azure Search is newer, it's a bit too new. I don't know if it's out of preview yet, but it's not been around very long. Elasticsearch keeps all the Lucene terminology. So if you've learned the low-level Lucene stuff like I've shown you, you can pick up Elasticsearch straight away. It hasn't transformed everything. Whereas Azure Search, they've completely changed the API. It's simpler in some places to use, but it's definitely more limited. And finally, if you do decide you want to make a big cluster of Elasticsearch, then it gets a little bit tricky. You need to kind of know what you're doing to set up your networking and your cluster configuration, where I think with Azure, it's more expensive, but it's managed for you. You just move a scale, and you get more search. You just put money in, and you get search capability out. Overall, with my tips, if you're looking to index something, say something that's in your database, the first thing I would do is probably create a custom model for that indexing. There's generally something you want to index, or something about your index that's different to what you're storing. Quite common is to take all the different text fields and just merge them into one text field, so you can just run your search across the whole thing. Before you put any content in your index, strip the HTML out of it. It basically just gets in the way, because what you're looking for is words when you're doing a search. Also, if you don't strip the HTML when you're doing that hit highlighting stuff, you'll find that what hit highlighting does will take fragments of your text out. And if you've got HTML code in there, it might not take a whole HTML tag. So you'll end up at some point with a broken HTML and your page will just go weird. I found that trying out the low-level Lucene stuff helps you understand the high-level library. So because I've worked with Lucene before, when I then went to look at Elasticsearch or Azure Search, I had a much better idea of what's going on. If you've run it, hit the debugger, and had a look at what comes out of the objects, then you understand a lot more what's going on. And the next thing is remember that the index is not a database. There are fundamental differences in how it works. So you will have to behave differently. One of the key things is that when you put a field in an index, it's not guaranteed to be one of those fields. You can have many values for that one field. And finally, for me, I think my recommendation is the easiest way to get started right now, and you wanted to play with some searching, is just download an Elasticsearch instance and run it. It's very easy to do, it's free, it's a 5-minute job to download and start running, and straight away on your machine where you can poke it and play with it, you've got a search index that's very capable and you can start putting values in there. Search Review, we looked at indexes. We looked at Lucene, the open source index library that is the core engine. So basically everything you've seen is based on this very, very awesome core engine for Java called Lucene. We've looked at how Lucene.net is a port of that library that lets you add Lucene to a .NET application. We looked at Elasticsearch, which is a service that you can run that will run Lucene and give you a REST API to talk to that service. You can then use the .NET libraries, one called Nest, to actually talk to that system and index and query your documents. We also looked at Azure Search, another cloud search offering that's based on Elasticsearch. And finally, we had a few kind of summary and just tips that I've picked up over the time. My name has been Brendan, and I'd like to finish by thanking our sponsors, who have done a great job, and also thank you to all the organisers of DDD for making this possible. And please remember to fill out your feedback. Thank you.